Welcome to part 3 of our mechanical vibrations lesson. I have the last example on here, which calls back into that example one that we did in the last part of this lesson in part 2. But I have the mass and spin from example 1 are now attached to also a dash pot that provides 1 Newton of resistance for each meter per second of velocity. And the mass is set in motion with the same initial position, x of 0 is equal to 1, with initial velocity x prime of 0 is equal to -5. We want to find the position function of this mass, its new frequency and pseudo period of motion, its new time lag, and the times of its first 4 passages through the initial position, x is equal to 0. So if we recall, m for this is a half, k is 50, and from this now, c is 1. So 1/2 times x double prime plus x prime plus 50x is equal to 0. Would be our ordinary differential equation. Multiplying everything by 2 gives us x double prime plus 2x prime plus 100x is equal to 0. And the characteristic equation we could obtain from this. Characteristic equation is r squared plus 2r plus 100 is equal to 0. Trying to solve that, there's no roots of 100 that add, of positive 100 that add nicely to make positive 2. So completing the square would allow us to factor this. R plus 1 squared plus 99 would be equal to that 0. So divide 2 by 1 and divide by 2 by 2, excuse me, and then squaring that gives us the 1 from that. So based on that, the roots that we have would be equal to -1 plus and minus the square root of 99 times I. Those are complex conjugates. So x of t, not x. X of t would be equal to e to the -t times a times the cosine of the square root of 99 times t plus b times the sine of the square root of 99 times t. So the circular pseudo frequency, circular pseudo frequency for this would be omega sub 1, that being the square root of 99. And as a decimal, that is about 9.9499. The pseudo period would be t sub 1 is equal to 2 pi over omega sub 1. And that being 2 pi over the square root of 99. And that is about 0.6315 seconds. The frequency that we would have, I'll write that down here. Frequency is going to be v sub 1 equals 1 over t sub 1. So omega sub 1 divided by 2 pi. So in our case, square root of 99 divided by 2 pi. That will give us about 1.5836 hertz. So from that, using our initial conditions, x of 0 is equal to 1, and x prime of 0 is equal to -5 from example 1, which we also see on here too. This is going to give us our, this is going to give us that position function like what we got on example 1. But the derivative of that function is going to be x prime of t is equal to negative e to the negative t. And let me just make that negative more readable. So negative e to the negative t times a times the cosine of the square root of 99t plus b times the sine of the square root of 99t. Right, and that was just from the first part of that derivative. And actually, let me rewrite that down here just so we have more room to write this out. As you can imagine, taking the derivative of a product, it makes that big giant mess. Okay. Rewriting that is the first half of that derivative. The second half adds the square root of 99 times e to the negative t times negative a times the sine of the square root of 99t plus b times the cosine of the square root of 99t. There we go. If we put in 0 for x in the regular function, we get a to be 1. If we put 0 into the derivative we just wrote, we get negative a plus b times the square root of 99, and that is equal to negative 5. So from this, we get a to be 1, 1, and b to be negative 4 divided by the square root of 99. So we can simplify our position function a bit. X of t is e to the negative t times the cosine of the square root of 99t minus 4 over the square root of 99 times the sine of the square root of 99t power. So based on that, we have that amplitude c sub 1 times e to the negative t would be equal to the square root of 1 squared plus negative 4 over the square root of 99 squared times e to the negative t. So that makes the square root of 115 divided by the square root of 99 times e to the negative t. So that complete function makes x of t is equal to the square root of 115 divided by the square root of 99 times e to the negative t times the square root of 99 divided by the square root of 115 times the cosine of the square root of 99 times t minus 4 over the square root of 115 times the sine of the square root of 99t. And that makes the square root of 115 over 99 times e to the negative t times the cosine of the square root of 99t minus alpha sub 1. So alpha sub 1 must satisfy that the cosine of alpha sub 1 is equal to the square root of 99 over the square root of 115, and that, well, is a positive number. The sine of alpha sub 1 would be negative 4 divided by the square root of 115. That's less than 0. So just like before, we're in quadrant 4. And so let's find that alpha sub 1. Let me just erase above here, so we could see that calculation being done out. Okay, so this is going to make for angle alpha sub 1 to be 2 pi plus the inverse tangent of negative 4 divided by the square root of 115 divided by the square root of 99 divided by the square root of 115. So 2 pi minus the inverse tangent of 4 over the square root of 99. So about 5.9009. So this time lag, delta sub 1, is alpha sub 1 over omega sub 1. So that's about 0.5931 seconds. So our complete function, x of t, is going to be approximately the square root of 115 divided by 99 times e to the negative t times the cosine of the square root of 99 times t minus 5.9009. Let me know if you have any questions or concerns. Thank you.